Is our first day of Ruby. It's our first day of the back end. It's our first day of our second language, first day of Unit 3. So a lot of firsts. So I think what we'll do this morning is just walk through some pretty simple stuff in Ruby that should equate a lot to the things that we've seen for JavaScript already. So you're going to see a lot of familiar things today, and you're going to see some new things today. And I will show you along the way where things are the same and where things are going to be different, so we can kind of relate it back to our JavaScript knowledge. So let's see. So do I have VS Code open already? Yes. So normally in the past we have opened up VS Code in one window and our browser in the other. But for today, for the first time, we're going to have our terminal in one window, and we're going to have, let me see if I can put this in a spot that's good. And we're going to have VS Code on the other side. Because everything we do today, we're going to be running in the terminal. We're not going to be back in the world of the web, at least for a little bit. Right? At least this week, likely, we're going to stay primarily in our terminals for everything that we're going to do. Right? And then once we sort of get up to speed on Ruby and some database things, we'll start connecting these two worlds of the back end and the front end. So on the left-hand side here, I put this into week 8, day 1, intro to Ruby, and I have made for myself a helloworld.rb file. And you'll notice now new file extension .rb. This is the file extension that all of our Ruby code is going to have, as opposed to .js for all of our JavaScript code. And I think you all should have the icons set up so you get a nice Ruby icon instead of a JavaScript icon. So unlike JavaScript, we are not going to be running our Ruby code in the browser. We're going to be running it in the Ruby interpreter. And we're going to learn 2 Ruby interpreters, one that runs our files and one that's going to be interactive, kind of like the console. And we'll likely cover both of them today. So we're going to get used to running typing our code in VS Code and running our code from the terminal. So we've created this helloworld.rb file for Ruby. Let's kind of start where we started with JavaScript. If you can rewind your brains all the way back to the beginning of week 2. Let's define some variables. So we saw in JavaScript that we did variables like let name equal to Gavin. So we don't have to tell it the type of variable, whether it's a string or a number. In Ruby, we just say the name of the variable is equal to, and again, we talked about how this can be with double quotes or with single quotes. You're going to find that most of the time in Ruby, I'm going to type them with double quotes. Both are acceptable. Although you will find that single quotes are going to prevent you from doing string interpolation. We're going to see in a second. So there's no requirement to type them in double quotes. That's just the habit that I have because I want that string interpolation available to me. So let's save this file and let's see how we run it for the first time over in the terminal. So in the terminal, we'll type Ruby space and the name of the file we want Ruby to run for us. So our helloworld.rb just has name equal to Gavin. And then in the terminal, we'll run Ruby helloworld.rb. And it said nothing. Right, we got nothing output on the screen. We read Ruby hello world, and it just gave me my super long prompt again. Maybe I'll try and I'll make my prompt smaller. Right? Ruby hello world.rb, and we got nothing. Ruby by default, when we're evaluating variables, has nothing to print. Right? It won't output anything to the terminal unless we ask it to output something. So just because we assigned name equal to Gavin, Ruby doesn't give us any output on the other side. If we want to see the output of a variable, we have to ask Ruby to print it. In JavaScript, this was console log name. In Ruby, this is puts. That's short for put string. Please put the string and output it. Puts name is like console log. And now if I run my program, it will output my name. So puts is a built-in function to Ruby that puts a string to the output. So much like JavaScript, we can also assign numbers to variables. We can also print or puts the score. Right? But didn't I say that puts is for put string? Right? So Ruby will take my number and automatically turn it into a string for me and print it out. So puts will take whatever variable I give it and try and turn that into a string to print it to the screen. And numbers, when turned into a string, just say the value of the number. This is much like console.log in JavaScript, just prints out the number. So we've got a name and a score. Let's make another variable called, let's call it message. And what we want this to be is, Gavin, your score is 42. We print this message, and Gavin, your score is 42. This is great. It's kind of hard-coded to the name and the score. So let's change this. Let's make Gavin be, instead of hard-coded Gavin, the value that's inside of name. And instead of this hard-coded score, let's have this print the value of the score. So this is much like JavaScript's message equals backtick $name, your score is score. Right? In Ruby, we keep double quotes, and we use the hash or octothorpe. There's your new word of the day. Anybody know this is officially called the octothorpe? Right?
The hash symbol?
The hash symbol is called an octothorpe. Octothorpe. If you ever listen to this, there's a great podcast called 99% Invisible. For those of folks who have a long commute, 99% Invisible is an amazing podcast. It's about the design of things. And they have a whole episode dedicated to where this symbol for the hash comes from, why it's called the octothorpe, and where it came to be. It's really neat. So in Ruby, right, we double quotes instead of backticks, and the hash mark instead of the $, and still the braces to represent the space around the variable. Anybody know something else different that's changed between JavaScript and Ruby in this file?
Commenting out?
Yeah, the comments are different. Yeah, in Ruby, we use the hash mark for comments. So a hash mark starts a comment as opposed to the 2 slashes in JavaScript. And luckily for us, the command slash works, and it knows, oh, if this is Ruby and I do command slash, it will put hash mark comments for me. So it's sensitive to the language, the auto commenting command slash or alt slash. So luckily for us, it's smart enough to know that. But if you're going to type your own comment, now it's a single hash mark to start your comment. So we have our string and our number and our string interpolation and our puts. Let's make an array. So luckily for us, we don't have to make a new array, ints, etc. We have what we call array literals, right? Just like in JavaScript. Right? In JavaScript, this was scores equals to 142, 60, 12, 0, and 99. In Ruby, it is exactly the same syntax. Right? Nothing has changed. Let's put scores and see what we get. Oops. Oh, I have a random character here. Let's run this and see what we get. Now this is interesting. It printed my scores, but you'll notice that in Ruby, if I just print the scores, I get them vertically output. Put scores gives me 100, 42, 60, 12, 0, 99 on individual lines. So this is helpful, but not great. Question?
Would it be the same if you did that as a string?
No,
it probably wouldn't.
Yeah, would just give me a string. Yeah. So remember I said that the puts method stands for put string. When I put the string version of this array, I get them one on every line. So the puts method is very helpful for human output, but it's maybe not the best for programmers' output. So fortunately, Ruby gives us another version of puts that I like to call like the programmer's print, right? And I say programmer's print because it's just the letter P. This is going to give us programmer-friendly output. And you'll notice that when I do a P of scores, it prints it out kind of the same way I would have defined it in my editor. And it tries to give you a more friendly version that to a programmer, yeah, the bracket and the commas make sense, but to a user, maybe a list of numbers vertically makes more sense. So the P, I like to call the programmer's print or the debugging print. You'll notice that if I print P, the message, I get quote, Gavin, your score is 42. Because what's inside of message is a string. The programmer's print is actually going to show me that it's a string. If I puts message, like I did up here, I just see the string without the quotes. Right? Puts is more formatted for our users of our program, where P right, will show me the quotes. So we've got names and scores and, score and an array. Let's talk about adding things to array, because we kind of saw this in the very beginning of JavaScript as well.
Quick question.
Mm-hmm.
Will P still convert a number to a string?
No, P is going to print out the variable in its programmer's view. Right? So if I print out a number, I'm just going to see the number itself.
So it's not a string?
It's not a string, it's just a number.
Okay.
Right? So this is a good way of if I want to see what's inside of this variable, right? So if score instead had this, right? If score were the string 42, and I P print this, I get quote 42. Right? But if score is the number 42, I just get a 42. Right? That's just like if I puts the score, it doesn't matter if it's a number or a string, it's going to look the same. It's just the 4 and the 2. So if you're looking to print out something and you want to know, well, what is it? Right? I have this variable. As a programmer, I kind of care. Is it an array? Is it a string? Is it a number? I can use P to give me some more context for what kind of thing that is. Let's talk about adding to an array. Okay. So we saw in JavaScript, I'm going to say scores push 98. Hey, it looks like the same thing works here. Scores push 98. Now our scores has a 98 on the end. Same syntax works here. But you'll find this happens a lot in Ruby. There's not just one way of doing things. Right? I kind of mentioned that in Ruby, there's several ways of doing just about everything. And sometimes different words for the same thing. So we can use scores push 98, but there's also a version called the shovel operator, the less than, 75. So the shovel operator is going to take whatever this is and push it onto the end of this array. And even visually, it kind of looks like take this thing and put it on the end of this other thing. Right? So you'll find Ruby folks tend to program this way more than this way. And if we're going to put something on the end of the array, you're going to see more code like this than you are like this. But they do exactly the same thing. They put whatever's inside here on the end of that array. We talked about the fact that Ruby does not care that we're going to put a string on the end of our array of numbers, just like JavaScript did not care that we would put a string on the end of our array of numbers. They are both languages that are not strongly typed. Right? They're going to allow an array to contain multiple things. Right? Maybe normally you wouldn't do this, but JavaScript and Ruby are not going to prevent you from doing so. So you'll notice along the way, sorry, I'm losing my voice a little bit this morning, that we are putting parentheses around all of our puts and our p's. And I mentioned that this is optional. So you'll see that many Rubyists will say this, p scores, or puts name. Here's our p scores and our puts name. That went many times when calling functions like puts and p, we tend not to put the parentheses. But this is not the case all the time. You'll see here in a second when we write our own methods. Community is a little bit split. Some people will put the parentheses and some people will not put the parentheses. You'll find that for functions and methods that I create, I tend to put the parentheses. And for the built-in Ruby ones, I sometimes or will often leave them out. Right? And it just comes down to Ruby conventions. So let's talk now about making our own methods. So we have a method up here that printed name your score is score. Let's make our first method to say hello to a person. Let's start with just making a method that says hello. So in JavaScript, this might look like this is what this might look like in JavaScript. Right, we're making a little method here called hello. It takes no arguments, and what it does is print hello. In Ruby, this looks like this. Let me make it the same. The def keyword tells Ruby we're about to define a method. Okay. Def here is a keyword. It's a reserved word in the language that tells Ruby when you see def, what we're telling Ruby is we're about to teach you a new method. The thing that follows def is the name of the method. Then everything inside, up until the matching end, is the definition of the method. Okay? So def is kind of like the leading const or let. This is the name of our method. Here our arguments go. Eventually our arguments are going to show up here. And then the body of the method, and finally the end. Okay, so we don't have any opening braces, we just have the end. Def hello, let's put hello, let's call hello. Okay, and in Ruby we would put parentheses, hello and parentheses. But similar to JavaScript, where we don't put the parentheses around single things, Rubyus will tend to leave the parentheses off if there are no arguments to the method. So this will work as well. Just saying hello will call the method. This is different than in JavaScript. Right? In JavaScript, to call the method, we have to say hello like this. But if we just say hello, that just refers to the method itself. It does not call it. Right, this is like your onClick equals click method. Right? We have to put the parentheses around it to call it. In Ruby, the parentheses are optional, so this actually does call the method. So this is a little bit contextually different than in JavaScript, where if you leave the parentheses off, we're talking about the function itself, where in Ruby, if you leave the parentheses off, right, we're calling the function regardless. Right? And we'll see in a little bit why that's a good thing in Ruby and maybe sometimes not a good thing, right? When we get a little bit further down the road with our Ruby knowledge. Let's make another method that takes an argument. Let's call it greet instead of hello. So greet is going to take an argument and say hello to the person. So in JavaScript, greet might look like const greet is a method that takes a name and is a function that says console.log hello name. In Ruby, it's def greet again. But now we put the argument in parentheses here, and we use our double quotes, hello, name, greet name. You will see some Ruby folks define the function like this. That's also perfectly legal.
How'd you do it before?
With parentheses.
Oh, I see.
So the parentheses, even when we define a function, are optional. But this is the style that's more common. We're probably 90% this style in the community. But you'll find particularly programmers from Seattle leave out the parentheses, because the Seattle Ruby community is led by a couple folks who are not fond of parentheses. So they don't do parentheses and everybody kind of followed. So the Seattle style tends to be without the parentheses. I'm pretty sure that's right, it's the Seattle style. But pretty much everybody else, majority of Ruby folks put the parentheses. Then if we want to call the greet method, We put the parentheses, right? And in JavaScript, it's the same thing. It's either this or this. Okay, this is calling, and it's the same thing in Ruby. We call greet Gavin, and we get hello Gavin. If we wanted to pass a variable, it's the same thing. We put the name of the variable inside, and Ruby will look to see what's inside of that variable and pass that to the method just the same. And you'll notice that I'm using a slightly different vocabulary. I'm calling this the greet method. In Ruby, we refer to these as methods, not functions. So the terminology here is a little bit different. This is the greet method, whereas we call this the greet function. They pretty much mean the same thing. For all intents and purposes, they're the same thing. Greet, name, method, the function greet name. Right. Let's talk about functions that return something. So let's say we want to make a JavaScript function called double. Let's call it double number. Right. So in JavaScript, this would look like our math, return number times 2. In Ruby, will look like this. Pretty similar, right? Math is still the same, right? Pretty much all the math symbols are the same. Add, subtract, multiply, divide, modulus are all the same in Ruby and JavaScript. You'll find that those are pretty much the same in just about every language. We call it the same way. Let's put that in a variable so we can look at it. I'm going to start to leave these parentheses out in the places I normally leave parentheses out. So we get 84. Right? We take double number and we pass it the number 42. This will return 42 times 2. We'll put that into the answer variable, and then we print it out. Programmers print. But right, same rule in JavaScript where we don't need still applies here. So rather than do answer equals double number, let's see, 85 and p answer, right, I can just print what double number 85 returns. Right? I just want to programmer print double number 85 and I did double. Okay, that's what's going on. I doubled the number instead of doubling the number. Double the number.
That's cool. It asks you if you.
Yes. So somebody was really paying attention. This is a neat thing that came into Ruby in Ruby 2.3. Somebody had built a library called Did You Mean? And what it did was it looked for all of the errors in your program that were typos and said, I found a function that was named pretty similar, and then was make a suggestion. So now when Ruby, we have an error. This is our first error. This is what Ruby errors look like in our terminal. It says on line 97 in the file hello-world.rb, there's an undefined method dual number. And we're going to talk about what this main object here in a minute is. Well, maybe we'll talk about that tomorrow. We'll probably talk about that tomorrow. But this was a no method error. The kind of error we got was a no method error. So in Ruby, we've got different classifications of errors, and you're going to learn a lot of them because you're going to make a lot of them, right? I still do. But what's nice is Ruby now has that did you mean built in, and it says, I looked through all of your code for dual number for something pretty close. And it says, I didn't find dual number, but I found double number. Maybe that's what you meant. That's pretty handy, right? Especially for folks like me when you make typos. Double number, right? Doubled 85 is 170 to double the number. Question?
If you had said P or puts instead of return, would you have not had to call it?
Ah, yes. So inside of here, if this did P the number, then this function itself would do the printing. Right? So if I do double number 85 like this, I get 170 because the function itself is printing. Right? Let's put this return back because that's a good question. So we write functions in Ruby so often like this, or very small methods, you'll find that one of the things that Ruby folks strive for are very concise, short methods. Right? As a Ruby programmer, when my methods get over maybe 3 to 5 lines of code, my skin starts to itch. Like, oh, this method's really long. And there are even linters, code checkers, right? You've been using a linter along the way where it's kind of giving you like red errors in your code. You've seen those in JavaScript. There are ones built into Ruby that start to warn you when your functions get too long. But we write functions like this so often that just return some value that we can take the return keyword away. Because the last statement of a method that gets evaluated before the method ends is the return value of the method. So this statement here, number times 2, is the last statement in the method. Therefore, whatever it evaluates to automatically becomes the return. So with single line methods, we almost never write the return. If writing the return helps you, please write it. If this is confusing and this feels comfortable, awesome. Right? But just know you're going to see examples of code, and I'm likely going to write code like this. Just know that the return is implied. And this is one of the examples when I said on Friday that Ruby has things that are implicit versus being explicit. Right? This is the explicit version of this. I'm explicitly going to tell you on purpose, I'm going to say return number times 2. Right? In most languages, like JavaScript, you have to say return this value. Right? Otherwise, your functions return undefined. And you all kind of had those challenges in the beginning of JavaScript. Right? Ruby says, yes, that's fine. You can be explicit if you'd like. But if you like to be implicit and you want clearer, more concise syntax, leave the return off. And this will work just as well. And you're going to see this quite a bit when we go through Ruby. You also notice that Ruby uses the same 2-character indent that JavaScript does. Yay. Or at least the way we teach JavaScript it does. You'll find some JavaScripters will use 4 spaces or a tab. In Ruby, 99.9% of the people will use 2-space indent. Right? So you should just be, I think all of your VS codes will be set up for 2-space indent, and you'll be fine. So here's a little bit about implicit return. One thing to know is that everything in Ruby always returns a value, even puts. Right? Let's take a look at that in the second way we can run Ruby code, which I said was the interactive runtime. So Ruby space a file name takes all the code that we typed in the Ruby file and runs it. But like there is the console in DevTools, there is an interactive Ruby, and that's called IRB. And it stands for Interactive Ruby. When we do this, now we're inside of interactive Ruby. Your interactive Ruby prompt might look a little bit different than mine, because I've styled mine a little bit differently. But once you're inside of IRB, now we're at a prompt where we can type Ruby code like, let's do this, name equals Gavin. So this will evaluate this line immediately and then show me the result of that line. So I said everything in Ruby has some kind of return. The value of this statement, name equals Gavin, is the string Gavin. The value of score equals 42 is the value 42. The value of score times 2 is 84. If I take score and multiply by 2, I get 84. But score itself is still just 42. Score itself is still just 42.
So if we were doing that in JavaScript, it would say undefined under each.
Yeah, because in JavaScript, the value of assigning a variable is undefined. In Ruby, the value of assigning a variable is the thing you assigned. To me, that makes a little more sense. Feels a little bit more natural. Just a difference in the languages. Right. So we have name is Jason, and we puts name. It's going to do the action and return some value. And in Ruby, the value of putsing or put string value is nil. And this is like JavaScript's undefined. Right. So puts has the effect of printing something, but it itself returns a value, and that value is nil. There's nothing useful we get back from printing something, so its value is nil. The programmer's print is a little bit different. The programmer's print returns the thing. Right? So P, programmer print name, will do the same thing. It will print out the value and then return whatever that value was. And this is pretty helpful. What if our double number function had a bug in it? Let's imagine, oh, and by the way you get out of this is also Control D, or the keyword exit to get out of IRB.
Whenever you did the puts name, it gave back Jason and nil?
Mm-hmm. So puts name has the effect of printing out whatever's inside of that variable. And this part here is IRB saying, I ran this code, it did whatever it was going to do, and this is the result, the return of the puts method.
So if it's not a value, if it's not like a numeric value, it's going to say nil.
Yeah, but you notice that P name did something similar, right? It did its fancy printing, but the P method returns this. Right? It returns what it was given. So the reason why I say this is the programmer's print is, what if our double number had a bug in it? Right? What if this said number times 3? There's a bug. There's a bug in our program. Doubling 85 is 255, which it isn't. And I wanted to go figure out why. I can just insert a programmer's print right here. And since P returns the thing it was given, and Ruby returns the value of the last thing, this P here is like a little tap, like a little man in the middle, a tap in the middle of this code that will print this answer inside the function. And this is just an example of Ruby's niceness, that this 255 came from inside of that function. Right? It's the difference between puts and P. P also returns the value. Okay. Let's put our double number back to the way it was supposed to be. So if you look here, right, we put our answer into a variable called answer, and then we use that variable here. Well, just like in JavaScript, I can write whatever Ruby code I like inside of the braces here and call double number 85 inside of that interpolation. So any Ruby statement I could run on its own can be put inside of these braces. Right? Just like you can say triple 85 is 85 times 3. Right? We can do various math things inside of that, right? Very similar to JavaScript. Let's talk about Ruby strings. So if we take a look at what's inside of our name variable, we still have the name is Gavin. If we want the uppercase version of Gavin, we can call the .upcase method. This is just like JavaScript would be, let's see, const uppercase name is name.toUppercase parentheses. So you'll notice that I can call methods on objects, on variables, but in Ruby I don't have to put the parentheses at the end. The uppercase version is all caps Gavin. But the name variable has not been changed. Upcase itself does not change the value that's inside of name. It returns a new string that's been uppercase. Just like JavaScript's toUppercase doesn't change what's inside of name, it returns a new string. So here's another example of Ruby having conventions for things that are true 85 to 90% of the time. Many methods in Ruby have a mutating variant version, right? They have a version of the same name of thing that modifies the variable. So if we call name.upcase exclamation mark, we are changing what's inside of name. So now if we look at name, we get name. Now if we look at name, we get Gavin exclamation mark. Sorry, all caps Gavin, right? The exclamation mark didn't do that. The programmer who created upcase said, I'm going to give you two different versions of upcase. I'm going to give you upcase and upcase exclamation mark. And I'm going to say that the upcase version without the exclamation mark will make a new string, but the upcase version with the exclamation mark will give me a uppercase version and change the string itself. So you often have to read the documentation to know which version of the function is going to do which.
You said it just completely changes it. It doesn't change it for one time, it changes it forever?
Mm-hmm.
Okay.
Right? So upcase like this takes whatever inside of name and gives me back a new string where that string has been uppercased. Whereas name.upcase bang, we call these the bang methods, exclamation mark, takes whatever inside of name and forces it to uppercase.
So now if you print name, it's going to be an uppercase name?
Mm-hmm. Now if we look at name here, we get name, it's now Gavin. My lowercase name is gone and replaced with my uppercase version, exactly. And this is just a Ruby convention. It's not going to work every time. Right? You have to look at the documentation and see, does uppercase change name or does it not change name? And you go look at the documentation on uppercase on a string, you'll see that uppercase gives you back a new string. And then right below in the documentation, it'll say, hey, by the way, there's also a version with an exclamation mark on the end that changes it. And this is just a Ruby convention because Ruby allows us to have exclamation marks and question marks as part of our variable names and our method names. You'll find that Ruby developers will use that to their advantage. That the exclamation mark method, the bang version, tends to mutate in place, change in place. Or when we get into Rails, we'll see that the exclamation mark takes on even more meaning to it. Not because of the language itself, but because of how the developers use the language to give you information about what the method does based on its name. Question?
So would it throw an error if you said new name equals name dot uppercase?
So let's do this. New name is this. You read the documentation for exclamation mark version of uppercase, you'll see that it also returns the uppercase string. So name.uppercase does two things. It takes name and it uppercases it to itself and returns you the uppercased version of the string.
So they're both the same thing, basically.
Except that this one changes name. So this will give me uppercase name, but leave name alone. This one will give me an uppercase version of the name and change name. You just have to read the documentation to see which version of what does what.
I guess my question is if you only had the new name equals name dot uppercase exclamation point, if you only have that line, would it still permanently change name?
Yes, because all these lines here are independent of these lines.
Okay.
So imagine these lines here. Imagine the lines above did not exist.
Yeah.
All right. Name is Gavin. New name is name uppercase bang. Name is changed. And new name is also the uppercased version. All right. So just remember that the bang versions tend to change the variable that they're called on. Shane?
Does, whenever you do the upcase, does it change it for the ones above that printed the ones printed before?
No, because those are already printed and gone by.
Okay, so it reads it from top to bottom.
Yep, Ruby starts at the top and works its way down, just executing what we're doing.
Okay.
Right. Very similar to JavaScript, right? It doesn't go back. It can't go back and change something you've already outputted, right? It can't go back and change this puts Gavin way up here, right? Because
Okay.
it puts this way back on line 7. It had already done that and gone by. Right. So it's printing, it's printing, it's printing, it's printing. Oh, you changed what Gavin is now. I will now change that and continue on doing whatever it is you asked me to do.
Technically, you don't need to do the new name thing, 'cause it's meant to-
Exactly. Yeah. It happens to return you a copy of the string, but you really don't need it because you already have what you need. Name, uppercase, bang. So another convention we have in Ruby is we often have methods that return a Boolean, a true or a false. Right?
One more question. What was the question mark one? So that
Yeah, that's exactly where we're going.
Okay.
So let's make a method called, if we were doing this in JavaScript, we might say like, is a method called isEven. Right? In JavaScript, we might make a method const isEven, takes a number and returns a Boolean. Number divided by 2 gives you 0. Right? This is what a Boolean isEven might look like in JavaScript. So I can pass it a 4 and get back a true. Right? Because 4, when divided by 2, leaves 0 remainder. If I give it a 5, right, I'll get a false, because 5, when divided by 2, does not give me a 0 remainder. So this is what this would look like in JavaScript. in Ruby, you might write like this. Number mod 2 is 0. And notice that in Ruby, we only use the 2 equal sign. Because in Ruby, the double equals works the same way, the way you would think about it, right? We'll look at that in a second. Right? But in Ruby, we use the 2 equals for comparison. Right? And you might do something like an if statement now. If is even 4 puts, yup, it is even. This is what an if statement looks like in Ruby, much like an if statement in JavaScript. If is even 4 puts, yep, it's even. And we get, yep, it's even. But Ruby gives us the ability to have question mark methods. So typically when we're defining a method in Ruby that is a Boolean style method, we tend to end those method names in question marks, like asking a question. If is even, question mark. And you'll find that Rubyists tend to leave out the is part. So we might write a method even question mark. If even 4. So question marks on method names tend to convey to you that this method returns a Boolean. It's going to return a true or a false. If is even 4. Yep, it's even. If we wanted an else, we say else, and we define the else part. Let's put a 5 in here. Nope, it's odd. All right. Question?
The is underscore even, that's technically Taco Tuesday, right? But
Yeah, the name of the method doesn't matter, but you'll find that Ruby programmers tend to leave out the is, was type things because the question mark tends to cover that.
Okay.
If even question mark?
Okay.
Right. And we even so much so that we get an even method on numbers. So we don't even have to declare our own little even method because Ruby gives us one. And now I think we're at something that's almost like English. If for even, then puts this, else put that. This is our goal. This is Matt's goal when we're writing code in Ruby. We want it to almost sound like slightly broken English, right? It's close to English, but it's not quite English. If for even, then puts this to the screen. Puts this to the screen, else puts this on the screen. If for even, right? So let's say we were trying to say odd, right? Maybe what we want is, we don't want this, we want something that looks like this. If not for even, yep, it is odd. Right? This is what we would do in JavaScript. If not the thing, if for is not even, we would print it. Let's make something that is odd, like a 5. This is another example of Ruby working your way. So we have an even question mark method in Ruby, so we can write if for even. But this is kind of weird, right? If not 5 even, well, let's also give us an odd method. So often in Ruby, we will write 2 versions of the method. One that's the positive case and one that's kind of the alternate or negative case, right? So we wouldn't just write an even method. We would also write an odd method, so we don't have to say if not even. Well, what's not even? It's odd. Right? So if 5 is odd, print, yep, it's odd. It goes even further than that.
Don't tell me there's a prime method.
So
There is. There is. Oh my goodness, there is. Watch this. Require
Up to now.
prime. So if I say, hey Ruby, go bring your prime library in. Is 5 prime? Sure is. Let's make up a number. Nope, that number's not prime.
What are the chances?
Yeah. It's not prime because those are the factors of that number.
Wow.
That number is 23 times 743 times 13,723. Right? Just built into the language. I only have to require the prime library. This is kind of like our import in Ruby. Now, from the standard library, I have all of the prime capabilities on a number. If I tried this without that, it would tell me, I don't know what you mean by prime. I haven't learned what prime is on numbers yet. But then if I require prime, Ruby has learned how to determine if a number is prime.
So if you leave the question mark off of if 4 even and if 5 odd,
Yeah, it says, did you mean
okay. So
4
the-
even? Did you mean even, question mark?
Yeah,
It's part of the name of the method.
okay.
Just like when we wrote our own even up here, right?
Which is a different even.
Yeah, this is the one we wrote.
Yeah,
This is the one that Ruby gives us.
but the question mark in our case is only convention up there.
Yes.
When we define it, that's only,
Yes, it's just as much a part of the method name as the n is.
Mm-hmm.
right. But for the if statements, it's definitely a part of the actual
Yes.
method.
The name of the method is EVEN question mark. Right? The question mark is, to Ruby doesn't know that the question mark means anything. It's like Jason said, it's like an N. Right? Like the honey badger don't care.
So it's not like a ternary operator.
No.
case, it's just-
Yeah. We're going to see the question mark used in some other places, but here the question mark is part of the name of the method, right? Like when we wrote our own even method, we could have just left off the question mark, and then this would be our code, right?
You probably can't start a method with a question.
You cannot. And it also can't be in the middle. It has to be at the end. So the exclamation mark and the question mark are special in that they have to be the last character of the method name. We can't have EV question mark EN as our method name. This Ruby would give us an error. I'm almost sure, right? Even the syntax highlighters like WTF, like this doesn't make sense. And I think we're gonna get a syntax error in our code. Yep, syntax error, unexpected parentheses. I was expecting a semicolon or a new line.
It thinks en is the name of the first method of the argument.
Yeah.
Parentheses are optional.
Yeah, it thinks we're doing this, and it thinks like this is an argument. It's like all confused, right? So just remember that question marks and exclamation marks are special, and they just kind of give us a hint as to what kind of side effects or return value these methods are giving us. Right? So imagine we didn't write an odd, right? We didn't write an odd pair to our own custom even method, and you don't like this if not even question mark. Like, oh, that's a lot of syntax. If not even, then do this. Well, Ruby's like, oh, that's more. We have an unless. Unless this number is even, print, it is odd. So unless is like a backwards if. Only do the part when the condition is false. Right? Unless is a backwards if. Unless this thing is true, print this. Right? So we tend to see unlesses on their own without an else. It's unusual to see an unless else, right? Because then you could just write an if else. But unlesses on their own are fairly common in Ruby, typically because The name that goes here sounds better as an English sentence with the unless in front. There's no reason Ruby needs to have it other than semantics, other than word choice. Can you get a question?
Yeah, if you were gonna do like unless red, so is it unless is red?
So if we were having,
Parentheses car or something?
yeah, so let's imagine we had a method like, oops. So here's our red color, right? So it'd be unless red, blue, right? It'd be kind of the same thing. And tomorrow we're going to learn about objects and classes, because Ruby also has classes like JavaScript now has classes. And we'll see how we're going to make a car class or a person class or a dog class, and we'll see how methods apply there. But the same thing is here is true, right? Our red question mark method conveys to us, the programmer, that we're going to be getting a Boolean style result back, and then we have our ifs and our unlesses.
Why would you use unless instead of if?
Because this would be if not red. If you don't mind this syntax, go ahead and use it. Ruby's just giving you more options, right? This is one of the other differences between Ruby and many other languages, right? For instance, .NET, Java, JavaScript, etc. don't have an unless. They only have an if. So in those languages, you always have to write, if not red, do this. Ruby says, maybe unless is a better word, right? These two are the same.
Would that be the same as if red put
Right? So if this color, let's do this. Let's put this in a variable. Come on, type. Right? If this car is not red, print nope, not red. This is the same thing as unless the car is red, print nope, not red. These two statements here and here are exactly the same. But you notice that here I say if not, and here I say unless. So they're the same. If not is the same thing as saying unless and the same rest of the condition. So it's just a different word for if not. If you like writing if not, write if not. No challenges, no issue. If not red car, and unless red car, same thing. Right? Another example where in Ruby, there's more than one way to do something. Right? If we were sitting over in the .NET class, they'd be saying if not red, and there wouldn't be a question mark because they're not allowed to have question marks. Right? It's a little bit of the flexibility, a little bit of the conventions that Ruby has. Cool. Let's talk about loops. Right? We haven't done any loops yet, right? Let's take our scores. Let's take our scores variable and let's take a look at what's inside of it. Right? Our scores have these numbers in them. Let's write some loops. Let's make an index variable that's 0. Actually, before we do that, let's see what else arrays can do. Let's ask for the length of the scores array. Right? That's 8. Let's look at the size of that array. It's also 8. Ruby gives us 2 methods to figure out how long an array is, length and size. Because sometimes length is the word you want to use in your programming sentence, and sometimes size is the right word. But they're both exactly the same thing. I think we can also do I'm not sure this is going to work here. Yep, count also works. Length, size, and count are the same things. Right? Which word makes the most sense to you? That's the one you should use. Ruby's flexible. Right? Really surprising that this comes from a person who's a native speaker of Japanese, not a native speaker of English. Matt's English is fairly good, but it's only really gotten that good in the last years. He's like worked on his English. But like, kind of surprising, someone would give you, hey, we know that sometimes length, size, and count mean different things for different collections of things. So I'll give you all 3 words. Awesome. Let's do a loop. So let's make an index that starts out at 0. Let's make a while loop. So while some condition is true, let's say while index is less than, which one do we think is length, size, or count? Let's do length. While index is less than the score's length, do work here. So while index is less than the score's length, let's do some work. What we're going to do is we're going to get the scores array index. This is exactly the same in JavaScript, right? Array indexing here works exactly the same as it does in JavaScript, right? They're also 0 based, so scores bracket 0 gives us the first element, etc. And we can also do plus equals 1 here. We can't, unfortunately, do index plus plus. I don't think we can. Yeah, that doesn't work in Ruby still. But we do have plus equals 1. That's weird. Let me start this again. Number is 5. Right, we get 6. So we want to add 1 to index and go through the scores, but let's put the score. And this will let us print all of the scores: 100, 42, 60, 12, 0, 99, 98, 75. We also say the number at index is score. Right? If we wanted to print the index and the score, we can do that. This is a pretty basic while loop in Ruby. While something is true, do something. Let's look at getting some information from the user and asking a question. So let's pretend we are going to keep asking for somebody's name and adding that to a list of names until they give us a blank, and then we'll stop. So let's talk about the opposite of puts. Let's talk about gets. So puts print something to the screen. Gets is going to get something from the user. So now let's say name equals gets. Right? And gets is a function, so the parentheses are optional. Name equals gets with or without the parentheses is going to ask for name. Let's put a little prompt here. Puts what is your name? So we know we're doing something, because without it, what happens when we run this program is it sits there with the cursor blinking or just staring at us, waiting for us to type something. So I'll type in my name, and now name will have whatever I typed in from the input. If I type Tony, name now has Tony. I can see that if I program or print name. So gets is the opposite of puts. What is your name? Tony. Anything weird?
/n?
Yeah, there's a /n on the end of her name. The /n represents the enter key that I typed. So not only do I get TONI that I typed, but I also get the enter key that I typed. I get the full input, including that new line. That's what the N stands for, a new line, right? Just like on a typewriter, when you carriage return and line feed, right? New line was the old typewriter. You would turn the carriage, right? And then, you turn the drum, and then the carriage return would move the typewriter head to the left. That N actually represents the new line, like the rotation of the paper in a typewriter. That's where that comes from, right? Remember when I told you like my first experience with the computer was a teletype machine where I would type on a typewriter and it would literally type out? That new line is the paper rotating one line down. That's what that new line represents, if you can believe it, right? So if I want to get rid of that, right? If I want to get rid of that, I could do something like name without new line is name.chomp. Chomp is the method on strings that takes spaces, white space off the end of a string. That's what chomp does. So you'll find that anytime I experience a new method in Ruby, I'm like, what? Gavin says chomp takes white space off the end of a string. Let me play around with that. I'm going to go into the IRB playground and try the chomp method. So if I type Gavin chomp, I just get the string Gavin back. But what if I type Gavin and a space and I chomp? What if I do a new line? Aha! Right? It took the new line off the end of my string. That's kind of what I want with my Tony that I got back from my gets. Right? I don't want the new line in there. I just want the name. What is your name? Tony. I get back Tony. But if I never want that, I can chain methods together. If I have name as gets Tony, and I name chomp, I can string the return of gets, which returns a string, and chomp is a method on string, so I can chain them together. First, Ruby is going to do the gets, and then it's going to do the chomp. In JavaScript, that would look like this. Call the name, so the gets method, get back a string. Then, when that returns, the result of that goes into chomp. That takes the new line off. But in Ruby, we don't need the parentheses. So now I just get Tony. So I can say gets.chomp. And just print the name that I get back. What is your name? Jason. Jason. Question?
So with the gets method, when you put it under a puts, it means that it's waiting for some input? Or?
The puts is only a helpful thing for the user.
Okay.
Right? I only put the puts here because if my program just said gets.chomp, right, you just have the blinking cursor there and nobody would know what to type in. So the puts is like a little banner for the user.
Right.
Print a banner for the user. Then get a string chomp off the new line. Put the result in the variable name. Get a string from the user. and chomp off the new line, put the result in name, and finally programmer print what's in name.
So before you had name equals gets
Mm-hmm.
name?
Nope.
Or just
Gets.
Okay.
Gets is the method
So-
that gets something from the user. Puts is the method that puts something to the user. Get from the user, put to the user.
So when you say name equals gets, it is waiting for the user to put something in there.
Mm-hmm.
Okay.
Yep, it's waiting for me to type something and press enter.
Okay.
It's waiting for a line of input, including the new line, including the enter.
Yes.
And because of that, I have to chomp off the end of that new line.
Whenever you have a gets, does it stop all code below until you do what you're supposed to do?
Mm-hmm.
Okay.
Yeah, it is not asynchronous like JavaScript.
Okay.
It will literally wait there as long as it takes for me to type something in and press enter. It is not asynchronous.
So under the programmer print,
Mm-hmm.
if you use puts there instead of just the P, are you still gonna get like Tony/N?
No. So we don't, the slash n went away because of the chomp. Now if I do this, what is your name? Tony, it just says Tony.
If you don't have a chomp on there though, it
Right.
would look the same just without quotes.
Exactly.
Hmm.
Right? But it's tricking me because that new line is secretly in there. So what would happen if I said if name is Tony, hello Tony. So if the name is Tony, say hello Tony. If I type T-O-N-I and press enter, nope. Because name has that funny little new line in it. Even though if you puts that variable, it doesn't look like it's there because it's invisible. That's why the P method is so helpful when you're like, what is really in this variable? So this is why we add the chomp on the end here. Now, this variable really has T-O-N-I in it. What is your name? Tony? Hello, Tony. This is why the puts for users is nice, but it can be a little bit deceiving, right? Because these two things look the same. What is your name? Tony? Tony. Chomp. What is your name? Tony. Tony. Hello, Tony. The puts kind of hides some things from us sometimes, which is good, right, for the user. But for the programmer, when we want to know what's in that thing, that's why the P method is so helpful. Question? Oh, sorry, Kenny had a question.
Yeah, when you first showed this to us, you typed in like say Tony space and it didn't take the space off.
Yeah,
It's just the
just the new line.
Okay.
Yeah. Yeah. Sorry, did you have another question, Michelle?
I guess I'm just trying to understand why it didn't put hello Tony, because it's not with, you can't see the new line it's adding in, so it doesn't match the name
Right.
there.
So if I leave the chomp off, I'd have to compare it to Tony N.
Okay, got it.
Then it would work. So her name isn't Tony and a new line. Her name is just Tony. So I want to make sure when I get input from the user that I chomp off those new lines. I kind of wish Gets didn't put them there, but that's what Ruby does, so we have to take them off. Ruby's going to put them in, we take them off. So now if we want to do a while, do you have a question, Shane?
Yes. What's the purpose of the slash in? Like, is there like a good purpose for it?
Mm-hmm. So let's say we wanted to, what if we wanted to say, hello, Tony, puts, you can play the game. Right, we're going to make a little game. That's what your homework is going to be. And you want to print, hello, Tony, you can play the game. But you wanted to do that in one string. You could say, hello, Tony, new line, you can play the game. So the slash n in the middle of a string will break to a new line right in the middle.
Yeah, like line break.
Exactly. Just like a BR in Java in HTML. Yep. Tony, hello Tony, you can play the game. What if we wanted a little banner? And then like 5 new lines of space.
Okay.
Here's a cool thing. See how I had to type out all those stars? Remember in JavaScript when we said like we could take 4 times 5, but we couldn't take b times 5 or star times 80? Like multiplication didn't work for strings? It does in Ruby. Right, so if I take a star and I multiply it by 80, anybody want to guess what it's going to do?
Give me 80 stars.
It gives me 80 stars across the screen. What? So if I want puts, right, times 40, right, and what if I want 5 new lines? Tony, right? I get exactly 40 stars and exactly 5 new lines. And then, hello Tony, you can play the game, right? So again, right, if you know the conventions, you know that strings right, you can get 42 Gavins, right? Right. Unfortunately, then there's no division. There's a proposal for division of strings, but dividing strings doesn't work, but multiplying does. And also, adding doesn't work this way or this way. Right. But adding 2 strings together does.
Even if the string was a number?
Mm-hmm. Well, if the string is a number, that works,
Okay.
right? But you can add 2 strings together, they just append, right? But you can't multiply 2 strings, but you can multiply a string times a number, and it repeats. So let's write this little while loop here, because this will help you with your homework. So while the name is not an empty string, while the name is not an empty string, puts give me another name, get a name, say thanks name, and repeat. So now, when we run our program, Tony, hi Tony, you can play the game. Sorry, I meant to say while the name is not. Sorry, nobody called me out. Sorry, the name is, while the name is, so if you're confused, they'd be like, hey, whoa, dude. If the name is not,
I was getting there.
give me another name. Gavin, Mark, Jason. Right. Right. It still gives me one more thanks because I'm going to print this otherwise. Right. So the while loop can use a variable that we have from inside here, right? As long as we've declared it one time before we try to use it. Right? Because we had the name here first, the while loop can see it. This will change the value of that name and evaluate the while loop over and over. Let's do the thing where we said we were going to make an array of these things. So let's add to this, just so you can kind of see your array looping, which you don't need for your homework tonight, but we're going to start using tomorrow. So let's make a new array of names. Right? And rather than this, let's take names and append name. Right? We can do it this way. Alternatively, we could call the push method, right? Same thing from JavaScript, the push method works. You're just gonna find that Ruby programmers are gonna use the shovel operator, the less than operator more often, right? And now, let's do the same thing here. Let's shovel names onto the end. And when we're done, right, here doesn't the word count kind of make more sense than length or size? You gave me names, count names, right? So we'll use count here. Tony, Gavin, Mark. It says we gave 4 names, right? We didn't really because that last name was empty. So maybe we need an if statement here. If name is not empty, if the name is not empty string, this. You'll notice that in Ruby, we can compare strings to empty strings. You all ran into this in JavaScript, where if you tried to do this in JavaScript, you got a logical problem, right? If we try to do this, name is blank, right? I take that back. What was it we were trying to? Oh, it was empty arrays. It was empty arrays. You had this problem in JavaScript where you said names is empty array, right? In Ruby, Ruby knows how to compare 2 empty things, 2 empty arrays, 2 empty strings consistently. So this is the case where if you didn't like the not equals to, we could do this. Tony, Gavin, Mark, empty. You gave me 3 names. We even have helper methods in Ruby called empty. Is this name empty? Nope. Is this name empty? Yep. So instead of this, we could say and here we can use empty, except we have to do, while the name is not empty, do this. Tony, Jason, Gavin, 3 names. But this is weird. So we also have until. So until is the opposite of a while. Until the name is empty, keep doing this. I think that reads better. Until the name is empty, print, give me another name. Unless the name is empty, do this work. Right? If while nots and if nots are more friendly to you, do them. If not, use untils and unlesses. This is the nice thing about Ruby syntax. It's a little flexible. So until the name is empty, do something. And then you gave me names, count names. Names.size, names.length would have also worked. Let's talk quickly about iterating through arrays. We want to go through all the arrays. In JavaScript, this might look like names for each name, little function, console.log name. Right? In Ruby, it is names each do name puts name.
I'm sorry to go back a little bit. To me, that last method is saying the same thing. Can you help distinguish the difference?
Which
method?
one?
The until name.empty and the less.
Mhm.
What's the difference between those 2 different?
So while says keep doing this over and over and over again while the name is not empty.
Okay.
or unless the name is not empty. Sorry, until. Unless is like an opposite if. It only does it one time. So this unless is like if not. We can use any combination of these. We can say until or while not here, and we can say if not or unless here. They're complements of each other, the while and the until, and the if and the unless. So an if statement will only just do something once. If this is true, do the thing inside once. Where a while statement will keep doing something over and over, keep checking that truth, right? Like, while I keep making baskets, I keep getting more points, right? And as soon as I stop making basket, I don't get any more points, right? Keep doing this thing over and over and over again, right? And as soon as that becomes false, stop. Right? An if statement, do the thing inside once and keep continuing with the code below. So we loop in here over and over and over again as long as the name is not empty. Right? That's why until name empty is the same. Until the name is empty, keep doing this work until you give me a name variable that's empty.
Why did, sorry.
No.
Why did you have to put the second if clause in there if name is not empty? Because you're kind of doing that.
Right. Because what will happen here, let's finish this and you'll see.
Yeah.
So let's print out all the names. Right? They are, and let's print out the name like with a little dash so we can see them. All right. So let's do it with the little if statement. What is your name? Tony, Gavin, Mark. Empty. You gave me 3 names. They are Tony, Gavin, and Mark. What if I don't have this if statement here? Right. And if I don't have this if statement, what is your name? Tony, Gavin, Mark, Jason, blank. You gave me 5 names. They are Tony, Gavin, Mark, Jason, and blank. Because this names, append names, thanks name happens regardless of this while. I'm only checking the while when I'm done with the loop. While the name is not empty, do this, do this, do this, do this, check the while statement. If it's still true, do this, do this, do this, do this, come back and check the while statement. Right? So if I don't actually want that blank entry in there, I have to check if it's not empty. Only append it if it's not empty inside of my while. Right? Because I don't want that blank entry in my results. And here is my printing. Right? Mostly to show you while, not, and until, and if not, and unless. Until.
So it has more to do with how the while loop works because
The while loop's going to do all the statements inside over and over and over again, checking the condition at the end of that block of code. It's going to do everything inside, then check. Then do everything inside, and then check. Check, do everything inside, and then check. It's not going to stop the second something becomes false. It's only going to check that condition at the end. It's kind of like that middle condition of a for loop, right? We did everything inside of the for loop, and at the end, we checked that condition. That's what a while statement is kind of like. Hint, you're probably going to need one for tonight's homework.
A while loop?
Mm-hmm.
Use this until, unless the...
Depends on what style you like.
Okay.
That's a while versus until is a stylistic choice. Just remember they're kind of opposites of each other. While keeps going as long as the condition is true. Until keeps going as long as the condition is false. An if statement will do the block if the condition is true, an unless statement will do the block of code as long as the condition is false. So they're kind of opposites of each other. If, unless, and while and until. Right?
So
It's
what's-
it's one of the things of Ruby that other languages don't have, right? If we were sitting over in the .NET class, they only have a while, they don't have until. They only have if, they don't have unless. Right? Ruby gives us different words depending on what syntax we like better.
Unless is the opposite of what?
Of if.
Of if.
If is the opposite of unless. Until is the opposite of while. Right? While you are less than 21, you cannot drink. Until you are 21, you cannot drink. Right? If you are 21, you may enter this bar. Right? Unless you cannot enter the bar. Opposite.
Until you're 21, unless you're in Europe.
Right. Right. Or Canada, or many other places. Right? They're just opposites. And they're opposites because sometimes the rest of the sentence, if you read the code out loud, sounds better. Until the name is empty, blah, blah, blah. Unless the name is empty, add this name to the end. Right? The opposite would be while the not name empty, or while the name is not empty, do this. If the name is not empty, do this. It's only a question of semantics and what sounds better to you as the reader of the code. Ruby does not care which style you use, as long as semantically it does what you want, as long as logically it does what you want it to do. Right? So we've covered strings. They work a lot like JavaScript strings. The rule here is the double quotes are what give us the interpolation with the hash mark or the octothorpe, as opposed to the backticks and the $sign. Our arrays are pretty similar, right? How we declare them. We learned puts and p. Puts is like the human printing, and p is the programmer printing. We can push things onto the end of arrays or shovel them on. We defined a method with no arguments. And then we called it, where we said we can call it with the parentheses or call it without the parentheses. That's a little bit different than JavaScript. In JavaScript, we always have to put the parentheses, because without the parentheses, we're referring to the function, we're not calling it. We declare arguments to functions or methods here inside parentheses, and then we can use them. And then once we have an argument to a method, we add the parentheses typically. We said when we take an argument and we return a value, the return keyword here is optional. We can say return number times 2, or leave that return off, because the return value, the resulting value of a method in Ruby, is the value of the last expression, the last line of the method. Right? And then we said that inside of our interpolation, we can call methods and do math inside, just like we can do in JavaScript. We can call methods on strings and arrays like .push and .upcase. But we also talked about that many methods in Ruby have a mutating version where we have a bang at the end. That by convention, not by rule of the language, Ruby's not enforcing this, that functions, methods that end in an exclamation mark usually have a special behavior. Typically, it means that they change the variable itself. We said that also things that end in question marks tend to be Boolean methods. The thing that it returns is a true or a false, often useful in if statements and while statements, or until statements and unless statements. We talked about the difference between if and unless. And we talked a little bit about while statements for looping. While this index is less than the scores length, get the indexed element of scores and print it, and then add one to index and loop. Right? Later on, we saw this is kind of silly. This is in the very beginning when we had our for statements with JavaScript before we learned for each. This is kind of how we did things. This is much easier. This is our names each do name, print a name, right? And then a little example of using while and unless and getting input from the user. So that's what you're going to need for tonight's homework, right? Is getting information from the user, doing some logic and some looping. For tonight's homework, you're going to get a JavaScript version of a program and be asked to write the Ruby version of it. And if any of you have come to any of the crash courses, you've seen us do the number guesser, right? The computer is going to pick a number randomly between 1 and 100, right? Or sorry, you're going to guess a number between 1 and 100. The computer is going to guess your number, right? We're going to show you the JavaScript version of that, and you're going to write the Ruby version of it, right? And turn that in. Any questions on what we've seen? Hopefully you see some similarities back to JavaScript in some ways, right? And some differences, right? Just based on the choice that the language made as to how it's going to do things.
How do you make a Ruby app?
Ah, cool. So let's talk about making a Ruby app and turning in a Ruby app. So this is going to be a little different. So let's go into where you might keep your core information. Let's go into SDG. Let's go into, and then, so you're probably going to be working in Unit 3. And you're now going to have to make the directory yourself.
Every time?
At least for a while.
Okay.
So you're going to make a directory, in this case, let's call it like number guesser. And you're going to go into the number guesser folder. And you're going to do two things. You're going to get init. So this turns your directory into a Git project. And you're going to hub create. You're going to inside that folder you just created, you're going to git init and hub create. The git init says this folder is now a Git project, so it's going to keep track of your code. And hub create says this is also a GitHub project. So when you push your code, it will go to GitHub. So these are two things that AppApp has done for you in the past. And Create React has done some of this for you in the past. It's done the get init part, but it didn't do the hub create part. So now you kind of have to do each of these parts yourself.
What if we don't have hub create?
You should be able to install it under Linux.
Is it just called hub? Or what?
It should just be called hub. If it's not, I'll find out what the package is called. It's likely just called hub. If it isn't, we can find the homepage for the hub project and it'll tell us what to install. But I imagine it's probably just called hub. And from this point, you proceed as usual. Code dot. And now you make your own Ruby files yourself, just like you made your own JavaScript files before, right? You're going to come up with a name, right? Maybe main.rb, or maybe you call it guesser.rb. There are no hard and fast rules for what you call it, right? Some people call it main.rb, app.rb, program.rb. This is number guesser. Maybe you call it number guesser. .rb. Any of those names are fine. App.rb. and start typing your code. Just like I did this morning with name equals, puts, gets, loops, etc. And you run it with Ruby space the name of your app.
For your terminal, how do you get that working?
So, right? So just like you have your terminal here, right? Your terminal probably looks a little bit different, right? So just like we were doing before, we'll put code on the side, and then rather than find and click on your browser, you're going to find and click on that terminal and put that on the other side. So side by side, you're going to have VS Code and your terminal.
What command were you doing to make everything show up?
No command, right? Just like before. So let me exit.
Do we have to type in IRB in the terminal?
Nope.
No.
So in your terminal, you're just sitting here in your terminal, right? You would just type code dot, right? Code dot was the last command that I ran. Normally you would type what? Yarn start. There's no yarn start here because we're not on the webs, right? We have no webs project yet, so we're not going to yarn start. So I'm going to make my VS Code full screen, and I'm going to choose my terminal to be my second half of my screen. Normally this would be where Chrome would be. Now your terminal is going to be, because we're making terminal applications now, not web applications. I'm going to start typing my code. Puts welcome to number guesser. Whole bunch of exclamation marks. Now if I want to run my code, I type ruby app.rb. Welcome to number guesser. I change my code, right? Think of a number between 1 and 100. I want to run my code. I will ruby app.rb again.
So it's just Ruby and whatever your file name is.
Whatever your file name is. Ruby space your file name.
So it doesn't automatically put like a console log would.
It does, but console log and puts are the same thing.
Right. But you have to do the Ruby app RB every time.
Mm-hmm. So there's no automatic reloading of your app. This afternoon, if some of you are interested, I will show you how to, in the terminal here, to have it reload your application every time. But for now, you rerun your Ruby application each time you want it to run. Right? Every time you want your app to run, you type Ruby and the name of your Ruby
And it'll
script.
show everything you've done in the app.
It will process your app line by line. It's just like reloading your JavaScript app, and your JavaScript code runs. Right? It starts at the top of your file and executes your code down the file until your code ends. And then it gives you your terminal back. Right? Name equals gets.chomp. Whoops. What is your name?
Spelled this.
Yeah, I just saw that. I will defeat you. Name. Right? Whatever code I put in here, as I add more code and rerun my program, right? Now when I run my program, it's asking me my name and telling me it will defeat me. And then I add more code and I run my program again. And I add more code and I run my program again. Right? It's the same loop that we were doing in JavaScript, except we're not in the browser. And I haven't shown you how to have your terminal program automatically reload when it's done.
Is there a key command so we don't have to type out Ruby?
No. What I tend to do is I use the up arrow and enter. And I will show you this afternoon how to have a command that will rerun your program. That's a little bit different than the web, because before, if you were sitting there waiting for somebody to click on a button, right, and you're like, oh shoot, I forgot a question mark, you could put the question mark in, it would reload your web page. Well, the web is asynchronous. So So it's not really sitting there waiting for you to do that. Here, even though I changed this code, this is now synchronous. It's waiting for me. So it doesn't know that I've changed the file. So I have to end my program by either typing in a name and finishing, or if my program is stuck, I have to use the Control and the C to end my program. Where's another place that we did Control C before? Yeah, while Yarn is running. So Yarn is a synchronous program. It took over control of your terminal until you told it to stop. So your Ruby program is a lot like Yarn. It's going to run and stay there until the program ends naturally or you tell it to stop. Right? So my program will end naturally if I type in Gavin and press enter, because it's run off the bottom of the program. But while it's waiting for me to type in my name, right, my terminal has been given over to Ruby. It will stay there until either this program ends by running off the end, or I tell it to stop with Control C. So if for some reason your program gets stuck, maybe your while loop isn't right, and your program is stuck and you can't get out, in order to reload your Ruby application, you can always Control C to terminate it. Right? And then you can run your Ruby program again. Make sense? Yeah. Cool. I will post the homework. And then you'll notice in many of the homeworks, there's going to be a section for the .NET students and a section for the Ruby students. So read the general instructions and then read the specific instructions just for the Ruby folks. And then I will look up for Kenny for you for the Ruby on Windows example. And I'll share that with you, Chris, as well, in case you want to try, and for some reason you want to have it in the Windows environment too. I don't know if you're booting a VM or you just like dual booting your...
It's dual boot, so.
Is that?
It's dual boot.
Dual boot, okay. So in case for some reason you want, while you're in the Windows side, to also be able to run Ruby, it's a pretty quote-unquote simple set of instructions. If you're willing to be a guinea pig, try it. If not, then I will, I'll go through the instructions and then share the blog post that I found. Any questions? Seem okay? Are we like still a little bit in the honeymoon phase of like some of this stuff seems familiar, but not too terribly different?
I just want to reiterate while loops. So it does all the code and then checks the condition?
Yes.
That's crazy.
Yeah, it does all the code and then comes back and checks the condition and does all the code and then checks the condition. It checks the condition once at the top, does all the code, checks, does all the code, checks.
So if you had more non-empty strings, names after the empty string, would it stop right after that empty string?
It would have stopped that one time because that was what was enough to terminate.
Right. It's the same as in JavaScript then. It'll still run.
Mm-hmm. Yeah. At the end of this while loop, go back to our while loop example, or our until loop, it's gonna do all of this code. It's gonna do this check once, then do all the code, then check again, then do all the code, then check again. As soon as this until loop or while loop needs to end, it will continue on with the rest of the code from here. Until name is empty, you're stuck inside of here. Right? As soon as this condition is no longer true, it will proceed to the next line. Until the name is empty, do whatever is inside of here.
So it does check the condition first before it does the code.
It'll do it once before it does the code, then do all the code, then check it again.
Okay.
So it'll include the untrue condition and then terminate.
Right? It does it once because if I had not typed in Tony's name here, right, it never would have done, if I had typed in nothing here, it never would have done this loop even once if this name was empty going in. Right? It's going to check it the very first time it sees it. If it's false, if this fails, if the name is empty, it won't even do this loop one time. right? Because it's like, nope, I can't do it. I'm going to jump all the way down here to line 199 and continue on. If the name isn't empty, then I'll do all of this and then check, is it empty now? And do all this and check again and do all this and check again.
So as soon as it's empty, shouldn't it not run the code at all?
You mean like right here?
Yeah, well, like, you remember you had to put the unless to make it not as an empty one?
Right.
To me, it seems like the condition there should stop it from even performing the code below it. And not even, like, worry about that.
So let's simplify this so it's not in the middle of a whole bunch of code. Let's save this and call this loop example.rb. Let's get rid of the appending. I just want this to greet me every time. Right? Give me another name. Get a name. Say hello. We'll say hello to the name once, and then we'll do this loop. Right? Get a name. Say hello name. Until the name is empty, give me another name. Ask for the name. Unless that name is empty, print the name and loop. If I run this, hello Gavin, give me another name. Tony. Hello Tony, give me another name. Mark. Hello Mark, give me another name. Jason. Give me another name. Empty. If I don't have this unless, here's what it's going to look like. Gavin, Tony, Mark, Jason, empty. I get one last hello empty. Now I could change this logic a little bit. I could put the hello here. But this looks a little weird. I'm saying hello before I ask for the name. Why does this work? Well, I'm priming, I'm putting something in that name variable, then I'm saying hello, then I'm asking for another name, and then I'm looping. This is the way you would do this without having to have that extra if. But I don't show that first because this is a little bit weird where I'm saying hello before I'm asking for the name. This works because I have one name here before I even start the loop. So in this case, Tony, Jason, Mark, empty. Get a new name, check if it's empty, then be done. Right? But in that case, I have to put the greeting before I ask. Now I don't need to check because the very last thing I do is I get a new name and then I check.
I think I understand. And it keeps going because it's not actually, because there's actually already there's a name there. So the gets is what's reassigning it, and then it finds out it's empty.
Yes.
So that's why it does that quote unquote extra time. That
Yes.
I'm kind of thinking. Okay.
If I had not declared that name variable first, you're actually going to get an error. It's going to say undefined local variable or method name because I haven't said what name is yet. Right? I have to, just like in JavaScript, I have to define the variable before I can use it. Right? So maybe we ask for a name, or maybe we just assign it a name and then start our while loop. Cool.
Do the get.chomp thing for when we're asking for a number?
Yep. So, but the thing is, what is that going to return? What does gets give us? Yeah, but if we do number equals gets.chomp, I type in 42, what did I get back? A string. right? So in JavaScript, we had parse int a string. In Ruby, we have toI. So that turns a string into a number. ToI says if I have a
Is
string,
it just an underscore? What does that mean?
it's an underscore. Because the way we separate, see how this is parse capital I
think the
int?
cursor was there.
Oh, sorry. It was like this.
Or would it be?
Yeah, 2I.
Okay.
So we can even chain all these together. Number is gets.chomp 2I. So get a string from the user, take off the new line, and turn this into a number. That's definitely a number. Whereas if we leave the 2I off, we definitely have a string. So if you need to be doing number-y kinds of things, less thans, greater thans, comparisons, you probably want to get chomp 2I. Get me something from the user, make sure you drop that new line, and then turn that into a number. And now you have a number from the input. What do you think happens if I type in tacos? What do you think number is going to be? Undefined. In Ruby, we call that nil. Anybody got any other guesses? Make some guesses. Nothing from the students in the back, nothing from the alumni in the back. If I take tacos and I try and turn it into a number, how many people think it's going to be like undefined or nil?
Oh, I think it's going to be a 5. That's my guess.
Somebody thinks so. So you think it's going to be a 5 because there's five letters? Okay, that's a good guess. How many people think my program is going to blow up with an error? How many people think something else? Yeah, probably not because it's Ruby. So no other guesses. It's just going to say tacos. So it's going to be a number. What number do you think it's going to be? What would be helpful to you? If you're like, it's not a number, so I'm going to put a 5. So it's not. I'm telling you, it's not 5.
Is it 0?
It's 0.
Plural tacos, so greater
Right.
than
Yeah. If 2I can't turn a string into something, it's going to give me 0. So now, what if you think I said 42 tacos? What do you think this is going to be as a number? 420. That's a good choice. Yeah. No, just 42. So it's gonna work on this string as it's a number until it finds something that's not a number and be like, that's where I'm gonna stop. All right. So we got 4. That's numbery. 2. That's numbery. So that's 42. A space. Well, that's not part of a number, so I'm gonna stop. What do you think this is going to be? 0. Right? Because it sees the T and it's like, oh, we're not dealing with numbers anymore. I got nothing, so I'm going to give you a 0. Right? So these are all things to think about when you're working with user input. Right? If you need to look at it before you turn it into a number, maybe you say something like input is gets.chomp. Maybe you do some if statement with the input. And then later on, you say number is input 2I. Because there's no way for us to know, if we just say 2I, if I say tacos, there's no way to know the difference between that and me actually typing in a 0. Right? At that point, I can't tell from the input variable, did you type in garbage? Or did you literally type a 0? Right? So maybe you don't want gets.chomp.2I, depending on what kind of checks, what kind of if statements you want to do around that input. But if you don't care, if you want to treat garbage input as a 0, right, do a 2I. Right? If you want the version where there is an error, there's an integer method with a capital I, and this one does care. If you give it tacos, your program stops with an error, right? And unlike in JavaScript where it just stops with the file you're on, this stops the program, right? You get this error and your program stops. So the capital I integer method says if you give me something that is not an integer, right, even 42 tacos doesn't become a 42. Right? The capital I integer method will give you an error. And there are sometimes reasons why you want that, because there's ways of handling errors that you might want. But for now, just know that probably the friendly way of doing this is doing 2i. 42, or 42 tacos, or tacos. 0, right? Same thing with a blank line, gives you a 0. Anything that can't be processed ends up being a 0. All helpful hints for tonight's homework. Questions? Anything else? Cool. All right. Tomorrow we're going to continue on with Ruby. We're going to see some other versions of iteration and looping. We'll talk about classes like we saw in JavaScript, and we'll see some things that are really familiar, and we'll see some things that are a little new, a little different. But hopefully you're seeing more things that are familiar to you than there are different. And if you walk away from this morning like, yeah, I saw some familiar things, saw a few things that are different. If you feel like more of it was familiar than was different, if you're getting that vibe, we're heading down a good track. That's kind of the vibe that I wanted for us to have for today. Cool.